Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new Delta X podcast with Ellen Shu. These are conversations with changemakers, innovators, and self-starters who have made their mark on the world at a young age, breaking down the journeys of those who are changing the status quo and building the future today. Knowledge is power, now more than ever.
And welcome back to Delta X podcast. I'm your host, Ellen Shu, and today we're going to be talking about, a little bit of brain stuff, BCIs, neurorobotics, and also a lot of research. So my guest today is Okezue Bell. He does neuromedical engineering research at Harvard. He's also worked on machine learning at Microsoft and the MIT Media Lab, and computational genetics and genomics at the Stanford School of Medicine. But I'm sure Okezue can do a much better job of introducing himself. What have you worked on and what gets you excited?
Yeah, thank you so much for having me. Well, I'll start with what gets me excited. I think the thing that gets me excited the most is the intersection between a variety of different fields and kind of just how they can come together to you either create a solution to something or just exploring it, which is why I think I liked research the most, because I wanted something that would allow me to have sort of like a creative medium, but at the same time still be involved in my primary interests, which are science engineering. So most recently, like you mentioned, I joined the MIT Media Lab, which was a crazy experience for me. It was one of the top places ever that I've ever wanted to be involved with. So when I got a response in the email and everything ended up working out, it was super cool. So the one I joined is the fluid interfaces group. So their main focus is creating different sort of cognitive tools, they like to call them, to kind of help humanity in a variety of different ways. So sometimes it might actually be a brain-oriented project, but what me and this other, a doctoral student at the MIT Media Lab are working on right now is a project that's actually on the website already. It's called Machinoia, Machine of Multiple Me. But we're trying to expand on that. So we're creating kind of different simulations of how a person would behave given their sentiment data. So emotional data, just previous data about them, and then creating future or different versions of them. And then using that to kind of inform their future decisions. So it's if you could talk to yourself, if you became a doctor, what would you act like, think like, things of that nature. And so what we've been doing is we've been kind of generating both from an image perspective of what you would look like, and then of course using things like GPT-3 to get audio and semantic information. So being able to basically talk to yourself, which is really funny, kind of we're talking to each other. And then outside of that, I've been working on another project, which is kind of more on the BCI side, which is building a prosthetic, simply put. So right now I'm actually reviewing some of the things for Sophia the robot, kind of her limbs and arms, which is fun. But outside of that, I am currently building my own prosthetic, which is why I've been doing research with Harvard Medical School, mainly just learning spectral analysis techniques, to analyze brain signals with a lot of high throughput, and also very in-depth. So just looking at different features of brain signals, which has been surprisingly interesting. At first, I thought it would be just a lot of math, almost very tiring, but it's turned out to be a really fun experience. Sometimes you just get this rainbow and you have to understand what it means on a spectrogram, right? So it's just really, really fun. Yeah.
Yeah, that's really cool. I mean, we should definitely talk about and touch upon neurorobotics more. And I've seen a lot of videos of Sophia the robot, so pretty cool in that aspect. But I think for now, I'd love to learn more about how you're able to, create these opportunities for yourself, because I assume that, at MIT Media Lab, they're not really having expecting high schoolers to come join the team. And they're doing all sorts of cool things too. I saw the other day, they're 3D printing pasta that changes shape when you put into water. That sounded awesome to me. But yeah, so how do you usually engineer these types of opportunities for yourself?
Mm-hmm. Yeah, I think the biggest thing is not having any fear. I know on the Media Lab site specifically, they say no high school students, basically. So I was really lucky in that respect. But honestly, I think one of the biggest things you can do for yourself is like really putting yourself out there. So if you know it's a place that's like slightly more rigid, one of the best things you can do is kind of like activate the opportunities that are already close to you, right? So I don't live in Boston, I live in Pennsylvania. So it's like we're still in New England, but it's still pretty far away. So it wasn't like the immediate place that was like, oh, I can just join because I live in Boston, right? It was a more difficult virtual thing. So I really started out like getting different lab experiences, contacting people at universities. There was even one point where I contacted like so many professors from my university and none of them responded. So it's just like kind of getting over that, I think is the biggest thing. Like sometimes they're just really busy. Sometimes they don't want to deal with a young person who just wants to do research but has no clue what they're doing. So like starting off with things like science fair, et cetera. But then if you really want to like take it to the next level and get these opportunities, I think the biggest thing is writing how you can give other people value, right? Because I think one of the biggest things that too often happens is like you're trying to extract value from these experiences. Of course, typically you're underqualified as a high school student to be joining a lab in the first place. So you really have to say like what unique perspectives you might bring or the main things that you want to learn. So I think just writing a detailed enough email that shows your passion, maybe some knowledge you have, and then also why it's important that you join this place specifically. Like there are thousands of really great labs across the world, but for me, MIT Media Lab really stuck out to me because of their like unique academic focuses. Like there aren't many labs that are focusing on something like social justice through technological mediums. Like there aren't many like labs like the Poetic Justice Lab, and there aren't many labs like the Fluid Interfaces Lab where they're working on a variety of things, but all towards this common goal of like enhancing human cognition. So I think, yeah, that's like a really long-winded answer, but to sum it up, it's like being detailed, being thorough, and also having some prior experiences to help like both boost your resume, if that makes sense.
Yeah. So were these like mainly, do you think the main factor was like a good cold email or like your past experiences? Since I did see you have like a lot of research experience as well.
Yeah, I think it was honestly a mixture of both. So I really started off in like the cellular agriculture field, which is like culturing proteins from cells, like just taking small biopsies from animals and using those to make different types of protein instead of, like cutting up a whole cow to make meat. You could just use its cells and grow meat like it's muscle tissue. So I think one of the biggest things that helped me was kind of having that prior background. So it all kind of clicked together. Like a lot of what I had done was already in like the cellular agriculture field from a variety of perspectives. Like even now I'm kind of still involved. So I'm working with this organization called the Cellular Agriculture Society. I'm helping them to write like a cellular agriculture textbook, which is like the first of its kind, which is super cool. And hopefully it'll help people get more into the field, like researchers, for example. But yeah, I think that definitely helped. But I think also it's like cellular agriculture and neuroscience aren't necessarily similar at all. So I think the first step is writing a good email and maybe having some experience behind that, just to like, like kind of impress the person that you're emailing, if that makes sense. Yeah. One other thing I try not to do is like over stress the fact that like I'm a high school student. I want to make it more about the research and more about my interests than about the fact that I'm like a teenager or whatever. So I think that is also helpful because it shows this like kind of sense of maturity. Sometimes they might forget that you're a high school student and add you to their lab unknowingly too. So it might work out. Yeah. So I think that, and then also when you have your first call with the person, leaving a good impression on the call is something that's huge. One of the biggest things you want, like I think one of the biggest indicators that you're leaving a good impression is like when you're both excited about what you're talking about and they're honestly willing to help you. And they say that too. So I think one of the biggest things, like asking really good questions too, like knowing what you're talking about, even if you've never worked in a BCI lab, you can still know about various topics. You could know about EEG channels, how to collect neural information. A lot of like scientific fields are moving computational now anyway. So I'm sure there are like different ways you can get into pretty much any field on your computer. Even just aside from like looking things up, you could probably program something, etc. So I'd say knowing how to code also is like a really big skill, because it opens up so many doors for you, like in terms of just doing independent research and independent projects first, so that you can still like get a kind of a taste of that field, so that when you're talking to someone in the field, you can actually have like a really educated conversation.
Yeah, for sure. And I think like one thing this reminds me of is how like all your experience kind of sort of compounds, and over time, like if you get started on one research, it makes the next one easier, and then like the more experience you have under the belt, it keeps getting easier and easier, and your experience tends to grow, as well as like your interest in a specific area. So where did that kind of cascade effect start for you? Like what was your first like break into research? And also maybe you could also tell me a bit about where you actually conducted it, because I'm really curious. Did you do cell agriculture just like in your garage, or did you do it in a lab? But yeah, that sounds like a really cool project.
Yeah, for sure. So I think my first main research experience was actually at home. So basically what I was doing was I was like, you can get like small different types of samples that you can actually get at home. A lot of people like buying like gene editing kits, etc. I actually didn't do that. I followed this one project that I'd seen online, bought all the similar materials, and then was able to do like, not culturing meat, of course, but I was able to culture things like from gelatin, materials, which is really fun. So I think working with anything wet lab, you have to be careful, and you probably won't find everything you need online. But if you're working with like non-living biological material, if that makes sense, it's kind of like an oxymoron saying non-living biological, but just anything that's not like currently alive or is mobile, you can definitely work with that at home. So yeah, it all started in my house. I also did like a lot of programming stuff. So that was fun. I do like research from both a computational and wet lab perspective. And then after I'd done that, that's when I started contacting like local laboratories, places like that. I actually didn't work in a lab for a while. I think my first real lab work experience was with the UPIT. Yeah, I would say it's with UPIT, partially because they're close enough by to me that I can actually like interact with them on a higher level. And that was all on like prosthetics, robotics stuff. So it was actually like way after my cell ag phase that I started working with them. But I did still do like scientific work. Like I worked with higher stakes. I was doing like a lot of literature research, things of that nature, some computational work. But yeah, I think I had like a weird experience too, because I started during COVID. So I was like, well, I guess I started like mid-COVID, because I didn't really realize that I wanted to do research until like COVID started hitting. So then I didn't get the chance to like go into a lot of my local university labs and work with them until much later. But I still got the experience. Like I still got to leverage kind of this new digital landscape that we had, like being able to contact people and you being able to do like virtual internships, which is great because you can now work with like any company anywhere because they'll just be on a Zoom call with you, et cetera. But yeah, that's basically where it started. It all started in my house. It kind of spiraled out of control until now.
Definitely spiraled out of control in a very, very great way. Yeah, I guess that kind of leads me into another thing I was curious about. You've done a lot of like research in different places. How do you balance like the different projects you're working on?
Yeah, that's a really good question. I think one of the biggest things I try to do is like have a document that has everything I'm currently doing, everything I might want to do, and then like everything I need to do. So I call it like my everything document. And then each day I kind of set out different priorities of things that I want to get done. But I think one of the biggest things you can do for yourself is like, whenever you pick up something new, have a plan for what a start and finish look like. So that way you can have different goals that you want to meet each day, every other day, every week, which is really helpful. So what I like to do is like plan out everything that I'm like, every new project that I start, have like at least like a start to finish plan, or a start to like a half finish, like finish the project. Maybe you don't stop working there, but you finish like one thing, and then move to the next thing. So yeah, I'd say that's like my biggest life hack. I don't really time block and things like that. which I still need to work on like time management stuff. But I think what's worked for me thus far has been kind of having a roadmap for each of the different things that I do. That way I'm able to cross something new off each day and like make sure that I'm still meeting deadlines and goals, et cetera.
Mhm. Yeah. And is there any other life hacks you have for like learning, for like being able to pick up topics, especially ones that like cell ag, I assume, like, and neurorobotics, they're not easy fields to get into?
Yeah, for sure. So I think one of the biggest things can be like joining programs. So for me, I joined TKS, which is where I was kind of introduced to a lot of these slightly more, I'd say, esoteric technologies. Like we all know about like AI, machine learning, all that, like the buzzwords. But when you get into like more interdisciplinary fields like cell ag, it starts to become a little more murky. So joining a program like that is helpful because sometimes you might not even be surrounded by like cell ag experts, but it's just nice to be in a community where a lot of people are interested in the similar thing. You can learn with them, things like that. But if you can't join a program, or you're just like, for some reason, it's like too much of a commitment, another thing you can do is like really great internet searches, just deep searches. Like if you start in one area, even though people like schools like to knock Wikipedia all the time, it's definitely a great source for learning, where you can like go down a rabbit hole. You can find out so many different things, and then it'll ultimately lead you to like a really good YouTube video. So that's like one of my top learning, especially for like fields that aren't so in your face. Definitely Wikipedia has been very helpful. And I think outside of that, this actually deals with school. It's like if you do like AP or IB at your school, that can be a really great opportunity for you to delve into like some more advanced topics. Like I know in my biology class, we actually, like one of the chats I had with my biology teacher, we were like talking about optogenetics, which is like how you can edit the genetic content of a nerve cell, so like a neuron, and get it to respond to light. And then from there, you can activate the neuron in so many different ways. Like they're helping to cure blindness with it and things like that. So it was during our genetics chapter that I actually learned about that. So like taking your courses of what you've been learning and actually just applying them, even as much as like school can become monotonous sometimes and things like that. I think if you're really excited about what you're learning, you can make it interesting by like going like one step deeper, because, you know, these are meant to be, as much as they say they're like college level courses, it's still meant to be like very introductory in a sense. So I think one of the biggest things you can do is like peel back the layers and really get into like a specific discipline. And then that ultimately leads you to like know what type of research you're interested in. Then you can start contacting labs, et cetera. So I think everything kind of ends up connecting, especially when you're interested in something like STEM, which is like, I'd say it's hard in the sense of learning, but it's easy in the sense of like, there's so many people doing it, and so many different people who you can talk to. And LinkedIn is also a great medium for that. And also Twitter. I don't use Twitter that much, but I found that a lot of people are talking on Twitter, and a lot of people like to meet on Twitter too. So if you have Twitter and you're like active on it, that can be really helpful as well.
Mm-hmm. Yeah. And I think what you mentioned about optogenetics is actually a great transition into talking more about, you know, the brain and your work with BCIs. So I saw that you worked on some pretty cool projects with BCIs, like brain and muscle controlled cars, music players, and now, like you mentioned, with your prosthetic device. So can you just talk about some of your projects, and also maybe like what gets you like interested in BCI for people who might not like be familiar with it?
Yeah. So I guess for anyone who doesn't know what BCIs are, they're essentially just like different ways you can interface with the brain. Thus like brain computer interface. It's any method in which you receive kind of brain signals or neural information in any shape or form. And then you use that to control something physical, like a car, for example. So all of our like neural processing is done with electricity, essentially. So it's all electric and chemical. So when we can record these chemical signals, what we can do is we can say, well, this certain range of hertz is correlated with some sort of movement or thing that we're thinking about. And whenever we break that threshold, we can control the contraction of an arm or like the playing of a music. And your muscles do a similar thing where they generate electricity when they're stimulated and move, because, you know, our brain controls our muscles too. So it kind of just works that way. But yeah, I think the reason why I got so interested in BCIs is because I was already interested in the brain, but I thought it would be even more interesting to look at ways in which we can not influence the brain, but instead influence the things around us with our brains, because I think it's a really unique modality because our brain is so complex and it has so many different like ways of conveying what we want, that it would be actually more effective to just read our neural signals and have that materialize in the real world. Of course, we're not really at that stage at all yet, but just like being able to work on something along those lines has been really interesting. So yeah, like you mentioned, I started off with some, I'd say like more simple projects in terms of like, or simpler projects. I mean, English teacher, if he sees this, is going to be very angry I said that. No, but some simpler projects I started with were like just controlling like different objects. So like controlling a music player, controlling a remote control car, different things like that, just controlling various things on my computer, like getting my mouse to move, random stuff. And then I started kind of getting into a more clinical application of BCI. So a lot of what we're doing now in terms of like medicine, or I guess what researchers are doing now, is intracortical BCIs, which is what Neuralink is, right? So they embed it within your brain, like an implant, for example. And then while it's inside of your brain, they can collect like really high fidelity signals, because, you know, it's in closer proximity to what's happening in your brain. So therefore the signals are better. And then they can manipulate a variety of things. So I actually did chat with like a lot of people in the different spaces, including a person from Neuralink. She was really nice. And she kind of got me into this whole idea of using BCIs for medical applications. And so one of the things I noticed was that a lot of prosthetics right now are not really great for especially like transhumeral amputees. So people have lost like their shoulder and below, or like below the elbow amputees as well. So just people have lost any part of their arm, really. I noticed that the prosthetic industry is not necessarily falling behind, but I have noticed that a lot of the current prosthetics today aren't helpful. Like it's a lot of body powered control, so it can be really difficult to use. When it is myoelectric, it's extremely expensive. And sometimes it's not very accurate. And what I noticed was like a lot of these really, really advanced prosthetics were still only being used in like clinical trials, kind of not necessarily deployed solutions yet. So I wanted to develop a prosthetic that could be deployed sooner. So I decided to do something that was non-invasive. So basically what I'm doing is I'm attaching electrodes to an amputee's residual limb, doing a whole bunch of things that I described previously, which was like spectral analysis is a great technique for analyzing neural signals. But more specifically, I'm using reinforcement learning to kind of collect these signals, determine what the amputee wants to do with the arm, and then that will correspond to like specific movements on the arm itself. And then in terms of the arm, I'm also doing some like mechanical changes with it, because I've noticed that a lot of prosthetics are very rigid. They're not like compliant. They can't bend properly. You know, the human body is very, very interesting in the sense that it's rigid, but it's also compliant. Like we have bones, which are kind of flexible, but they're not brittle, but they're still like dense and hard, or they're really not dense either. They're just hard components of our body. So when you can move with like a lot of flexibility, like I can bend my fingers backwards, that's something that's really, really amazing that a prosthetic can't do, or at least current prosthetics don't do. So I'm mixing soft and articulated robotic components. So soft being compliant, bendable, and articulated being more structural and rigid. And then combining those so that I can create a similar human-like bending effect. And that's all kind of encapsulated in this thing called anthropomorphism, which is like just modeling things after the human body. So that was a very long explanation of what I'm doing, which is just building a prosthetic that can be controlled by amputee muscle signals. But yeah, that's like my main project now. I started off with a couple of different things. Like there was one point where I was wanting to like cure different diseases, doing neurology research, which I'm still very interested in, but we'll see where that goes. But right now, yeah, I'm working on building that prosthetic. Just got some IRB approvals to do some testing on humans, which is very fun. And then I actually do have like one of my old models of the prosthetic, like sitting behind me. It's not composed, but I can definitely show. It's
Yeah,
like,
I'd love to see it.
you guys can't see this, but it's like different 3D printed components of my prosthetic.
Wow.
That are kind of like all apart. So this is like a wrist fixture, an arm, and of course this is the hand. Thank you to of course, this is all not assembled right now, but the UPIT lab, the Rehab Neural Engineering lab that I mentioned previously helped me print these. So that was really nice of them. But yeah, it's also really great to like do something like a prosthetic because I'm learning so many different things like SolidWorks, which is just like a CAD modeling software, which is super fun. Of course, live signal processing, which is really, really great skill if you ever want to work in neuroscience. So yeah, I've definitely been learning a lot with these projects. I'm also part of the Masterson Foundation, which is like by the founder of SoftBank. So through that, I'm getting like a couple of funding things, like I'm going to buy a 3D printer, a couple of like neural interfacing tools. So with that funding, I'll be able to do a lot of research in-house too, which is very fun. But yeah, that is my main project.
Yeah, that's really incredible. And it sounds like what you're doing is very interdisciplinary, like what you mentioned for like understanding the human brain and also like modeling, designing, all these different things coming together. But yeah, I loved how you also talked about your process to doing it, to like building smaller, like more fun, like projects, and then moving up to your current project. And I also saw on your website that you mentioned one of the adjectives you used to describe yourself was autodidactic, which I thought was very fitting, since you've learned a lot, obviously, on your own as like a high schooler. So besides like building projects or like learning through projects, is there any other place that you usually find resources or learning things that are above the high school level?
Yeah, for sure. So one of the main thing I love to do is like read. So my parents are engineers, which is helpful, of course. So we get like IEEE magazines and things like that. So looking through those sometimes, a lot of virtual and digital reading. Don't tell anyone, but I do tend to like pirate some of my books. So like these online, like the super thick, like nature books that are sometimes like thousands of dollars. Like one of the ones I read, I remember was like, it was like $1,000. And I was like, I'd rather just like, if I can get it online for free, I'd rather just do that. So that's what I did. It's like the Handbook of Heuristics, I believe it's called. And it has so many different things from like genetic algorithms to machine learning. So that's a great way to learn. Of course, when you're like getting into something like the Handbook of Heuristics, it's going to be very technical. So a lot of what I like to do is like highlight things, like even in like lower school, when they tell you to like highlight things you don't know, it's definitely a very good skill because then you can just search them up. And given your background, of course, you have to have already known something to be like reading this book in general. So I'm sure with just a simple definition, you'll be able to kind of understand what they're conveying. So reading is definitely like one of the number one ways to learn. And then also just observing other people. Like I mentioned, it's great to make friends and like outside of school and in different programs. So that way you can learn from them too. Kind of like we're doing now. Definitely a great way, just like talking to people, kids your age, because there are a shocking amount of young individuals like me and Ellen who are like doing research and like interested in computer science, et cetera. So definitely talking to them can be great, or just like having LinkedIn, I think is helpful just because people post a lot on there. You can find new things like recently because of CES happening, people are like posting, like showing off their new inventions from their companies. And it's all been really cool. Like I think it was like a Mika robot and it looked so human. Like it was like this gray robot. It honestly looked kind of creepy to me, but it was really cool because its face was like very well articulated. It looks so human like. So I think seeing things like that, even if you're not like currently involved in a research opportunity, is just really helpful because when you learn something like that, then you can start doing more specific searches, find more information. Kurzgesagt is also a great YouTube channel that I love to watch. Yes, a lot of people love Kurzgesagt, so I always mention it.
Animations on point. Like, they make me so happy.
Yeah, they're awesome. And I love how they have like the little birds throughout the video. They're so cute. Yeah, but Kurzgesaggt's definitely awesome. Insider is a really great YouTube channel as well. So I think it's just a lot of like consuming content and then trying to use that content to like create something of your own. What TKS likes to do is they like you to like do write articles. I do a lot of writing myself. I like enjoy writing a lot. But they do like a lot of article writing. And then you can do something like a replicate where you find a project that already exists and try to like do it again. I think that exercise is actually really great because it helps you learn and you also already have results to look at so that when you start your own project, you can kind of understand the things you need to do. But yeah, those are like my main learnings. I think a lot of it's just like observation, media consumption is helpful. Maybe like scientific news can be helpful too, because a lot of times they talk about like random things that you might be interested in. And then once you know what you're interested in or find something you're interested in, then being able to like look it up and really learn about it is something helpful too. And of course, books. Yeah.
Yeah. You mentioned humanoid robots. And so I know in the beginning, I promised that we would come back to that. Tell us more about Sophia the robot, what you're excited about in that area now.
Yeah, for sure. So like I mentioned, it's really like a prosthetic thing that I'm doing with Sophia right now. So like looking at the new models for her arms and hands and trying to like stress test them, understand better ways that they can be used. And also with my prosthetic, rolling it out with like hopefully with NGOs in different places to get it to the people who need it the most. Honestly, I think Sophia is really cool. Of course, there are some videos that are pretty creepy of her like saying creepy things. So I think that was intentional by Hansen Robotics. I talked to Dr. Hansen like actually a little bit ago. It's been a while now, but essentially we were just chatting about like the purpose of these, and the whole idea is that like the world has been built for humans. So if we want to create assistive technology, we also have to build like systems that can adapt to human behavior. So building humanoid robots is a huge step in that. Of course, I think Sophia's kind of corporeal form, like her body itself, why it's so human-like, I think is more of a human appeasal thing. Like it's easier to kind of interact with something that looks like you. But honestly, I think one of the biggest things that they're doing is like trying to develop this machine cortex where it can understand emotion, understand what facial expressions mean, like actually make connections. Because a lot of times, even when we're analyzing like emotional data, it's not the computer actually understanding what you're feeling. It's just like it converting that to some sort of like general, like just converting it to some sort of general program so that it can kind of draw conclusions, but it's not actually understanding the correlation between like your body language and your emotions, what you're saying, etc. So creating different algorithms that can actually take in like various forms of human data and actually understand and interpret them is really, really interesting. And I think that's what got me into the brain as well. It's like so many different connections that it makes, like, your neurons form new connections when you make memories, things like that. So that's like one of the biggest things. And I think that's one of the main points of building human-like robotics. I'm still waiting for Tesla to do something with that Tesla bot that they announced recently. I thought the mock-up of it looked really cool. And also the human body is like great for actually like physically doing things. Like I think that's a mechanical side that I'm interested in with Sophia, is like, because she's like shaped like a human, she can actually perform very difficult tasks for robots. Like if you've seen Boston Dynamics, you can see that they do have some like weird kind of shapes that they have to use. Their robots are really, really amazing, probably like one of the most advanced robots. But they do have to like adapt certain forms and shapes so that they can jump and hop and skip and lift up boxes. So when you have a human-like robot system that's like fully actuated, meaning it can move in all these different areas, there's an endless amount of activities that it can do. But of course, biology isn't that easy to replicate with nuts and bolts and screws and machine learning. So it'll take a while before we reach that point.
Yeah. And besides it being like incredibly cool how we can pretty much create such a realistic humanoid looking robot, what is like the main reason why we would want to create these things? Like, is it to, serve as assistants, to do like more manual labor things? I'm just really curious about that.
Yeah. To take over the human race and create a new race. No, I'm just kidding.
That is what would like Sophia the robot would say though.
Yeah, I
Let's not ask her anymore.
Yeah, exactly. No. But yeah, I think the main reason behind like giving robots human-like faces, giving them actual facial features is so that they can connect with human beings. I think that's been one of like the biggest kind of difficult to understand aspects of robotics is like this whole Turing test problem, where we're trying to create something that's so human-like it can actually blend in with human beings. And I think like I said before, like the world has been designed for us. So of course, creating something that at least resembles us is useful. But even beyond that, if you want to create something that's can do like therapeutic things, like be your therapist or help you, it would be helpful that they didn't look like a big hunk of metal or a screen, that they had like human emotions, human features, and were kind of somewhat like you. People also, there have been like some studies showing that people like things that look exactly like them too. So even creating like clonal copies of them, like from a robotic perspective, could be really interesting, like as a companion or someone that they can interact with, or even someone that like who wants to interact with themselves. I believe like one famous actress, she did this thing where she had like a robotic version of her constructed and then put in interviews, and waited to see like real interviews, like with real journalists, and then waited for the journalists to notice that it wasn't actually her, that it was a robot. And some of them got fooled. So it's things like that that are really interesting. Ultimately, down the line, I do think that the people might stop pouring like so much money into making like actual faces, but that some robots with like very human-like features will exist, kind of to be ambassadors or things like that. It sounds very weird talking about it, largely because I feel like it's so far away. But I think the main point behind it is just to create or see the bounds at which we can kind of replicate the way humans act, behave, and look like, with a goal of kind of implementing those in like a variety of different areas. So I doubt that we'll have like a bunch of Sophias just like walking around all the time, like being people's assistants, but instead we'll use like different parts of Sophia, like her code, maybe her arms, her legs, when she gets legs, kind of using those in different areas for a variety of purposes, whether it be in industry or in healthcare.
Yeah, it's interesting how you mentioned like there's both practical and kind of like emotional reasons for wanting like robots to assimilate better into, like human society. It's very interesting to think about how someday we might like talk to a robot friend, or like, I don't know, have like a robot therapist and stuff like that. But I'm sure it'll be a very interesting time to live in, and maybe we'll even live when, like, we will even be living when that happens.
Yeah.
But I have one final question that's kind of a more like lighthearted one. But I saw that a really cool video on your channel is one where you were playing Garry Kasparov in chess.
Yeah.
I thought that was really amazing. And I guess other than explaining kind of the backstory behind how that happened, what are some other like just unique life experiences that you've been able to like think back and remember?
Yeah. Playing Garry Kasparov, that was super cool. When I was younger, I used to do like a lot of competitive chess. Now, not so much, but it was still very fun. Like, I think I still have a bit of my game. I lost, of course. Fortunately, I still remember the mistake I made. I shouldn't have castled in that game. What was funny is that he actually played a defense. I play like this opening called the Tiger Modern, and he played an attack that a lot of people actually used to play against me. So I was like, wow, I could actually win this. And then he started making all these crazy moves, and I was just like, I don't know what I'm doing. So yeah, that went down the tubes, but it was still super cool. But I think one of the like other interesting experiences that I've had, I met the founder of BLM at the same event at Web Summit. That was super awesome. Yeah, just like, I think meeting people has been like the craziest thing. One of the funny things that happened was like I joined the Perfect Days Sustainability Board, later helped to found their Gen Z Council. But when I first started their sustainability board, one of the people on it was like Leonardo DiCaprio. Yeah, so it was like, whoa. And then like it was like published in my schools. Like we have something called like this kind of like school blog. So we were actually doing something with the Great Gatsby in class, and like then we like watched the movie for fun, and they were like, oh, Okezue, like, do you know Jay Gatsby, because like he's Leo DiCaprio. It was kind of very awkward and embarrassing. I think that's like a weird thing to be embarrassed about, but it was just like a weird experience.
Embarrassed
but I thought
about knowing Leonardo DiCaprio.
Yeah. But it was definitely like fun in the sense that it was like, wow, I'm very shocked that this is happening. Like I did the urgent company, and then I joined Perfect Day, and they were like, hey, do you want to be on this board? And I was like, whoa, of course. And it was just like a really surprising thing that happened. But yeah, I think that was one of the main things. Also, like meeting different researchers that I'd been seeing online. Like, for example, the head of the Fluid Interfaces Lab, Patty Mays, I had seen her do like an interview with, I forget who it was from Microsoft, but it was like one of the C-suites from Microsoft. I was like, wow, this lady's really, really cool. And then I got to meet her, of course, via Zoom, but it was still like, wow, I'm just like meeting all of these different people who have like the Google Knowledge Panel. Like when you look them up, like it says their thing. So it's just like, wow, this is so crazy. Being able to meet so many different people. And I think that's been kind of like the most eye-opening thing, is that really nobody's that mean that they won't want to talk to you. I mean, some people are, but I think most people that you look up to honestly are just like, the reason they're hard to reach is because they're so busy, or sometimes they don't even like manage their own emails. So I think when you do get to meet them, you just realize how open people are and how social, even people who are like introverted can be very social. So I just think it's like a really interesting experience to know, like, wow, these people are actually human. Like on the way to my talk, this is actually really funny, sorry. On the way to my talk, I bumped into the president of Microsoft, and I was like, oh, you're Brad Smith. He was
What are the chances? Wow.
Yeah, it was really crazy. And he was like, yep. And then I just kept going. I didn't even say anything else. I was like, hi, it's super cool that you're here. He was just like, yeah. And then I was like, wow, that's awesome. So yeah, I think it's just like things like that, because you see these people, a lot of them are like very successful people. Like you can imagine, he's the president of Microsoft. Of course, he's like doing very well. He's also like a really famous attorney and all of that. So it was just like, these people actually exist in real life. You might actually see them. Like, I think it was a similar thing to like a celebrity experience, except with like a tech celebrity. Cause I don't know many people would be that, like, I don't know that many people who would be like so excited about meeting Brad Smith if they didn't know who he actually was. But if you're in the tech space, it's a pretty cool thing. So I think it's just like, wow, these people are real people who you can interact with, who are actually like very nice and sociable. Like one of my director / friends, he met like Craig Federighi at the same event. I don't know how to say his last name. Federighi. I'm not sure. Hopefully if I meet him again, I'll ask him. But he's super cool. He's in like all of the Apple event ads and things that like he presents all of the new phones and stuff like that. I think he's like the head. He's like one of their heads of like one of the computer fields. But it's just really, really interesting. Like you see these people on videos and like in all these places, and then you see them actually walking around like being normal people. It also humanizes them in an aspect, because it really takes away that feeling like, whoa, these people are just like so far away, so amazing.
They're from Mars.
Yeah, exactly. But no, they're just like normal people who just are in that position because they did X, Y, and Z. So I think that has been like the biggest, craziest thing. And like, sometimes I just sit and think about it. I'm like, wow, I'm very lucky. But yeah, those have been kind of like the main experiences that I've had.
Yeah. And a quick follow-up to that. I know there's like different views on luck. If you've heard of like the 4 types of luck, and how, you can be lucky by just like sitting there, or you can be lucky by moving around, bumping into a lot of opportunities and getting luck, or I forgot one of them, but I know the last one's attracting luck. So how do you think you like kind of engineer luck in this way to be able to bump into so many cool people, and be able to be a part of these rooms where a lot of cool people are?
Yeah, I think one of the biggest things I like to do is like, I think I'm like the kind of I forget what it's called, but it's like directing motion or whatever. It was like one of the 4 types that you were talking about. I think I'm the one that like puts myself out there to so many different people that it gives me just like a naturally higher chance of getting some sort of successes. So I think that's like the biggest thing that I've done that's been helpful. And I'd say that's like kind of unique to myself is that I'm really not afraid to reach out to like anyone now. Like I will reach out as many times as I need to, like do follow-ups, just messaging people. I think I've gotten pretty good at like that emailing game. Like there was just one company that I was looking at that I was just really interested in, emailed the founders, like one of the co-founders, they responded. So it's like things like that. It's like, it's just been an amazing kind of luck engineering, like you called it. Where you're just putting yourself in so many spaces. And, emails don't take that long. So it's not like a huge commitment to just go out, email people. And, hopefully you get responses. And the more people you email, the higher chance that you'll have at least one response. And I think doing that has been helpful. Of course, there are like other ways that you can have that. Like sometimes you just meet people. I think meeting people is actually the best one because emailing people sometimes is a low chance. Sometimes it'll go to their junk spam mail. You just don't know what happens after you send the email. But when you are able to like meet a friend of a friend of a friend, eventually you'll get connected to the right people. So I think that's one of the biggest ones, especially for high school students. I think sometimes it's easier to like meet people, show your personality, and you'll ultimately get connected with so many different people along the way.
Definitely. Yeah. I mean, this podcast came from a cold email too. So
yeah, see,
yeah, it's really about just reaching out. But yeah, I think that's a great way to end up. You can engineer your own luck, and whoever's listening to this, definitely shoot more cold emails, and who knows where it end up. But yeah, thanks so much for coming on. This is a lot of fun. We talked about a lot from like PCIs to your research on like at the MIT Media Lab, like unique life experiences. Yeah, there's just so much that like this conversation touched upon. I'm really glad we were able to go on this conversational journey.
Yeah, it was so awesome. I'm really, really glad to have been on this podcast. Very unique. I've actually been seeing it around LinkedIn, so it's really exciting when you reached out. Yeah.
Oh, great. Yeah, I'm glad. And yeah, it was really great having you on. And I hope the listeners also enjoyed this. If you're listening to this right now, thank you so much for listening. And I'll link below some description notes, as well as some links that you can find Okezue at if you're open to that. And also make sure to subscribe to the newsletter to receive these types of podcast episodes every other week. All right, with that, see you guys next one.
We hope you enjoyed this episode of Delta X Podcast with Ellen Shu. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.